How many moles of helium are in a balloon that has a volume of 3.1 liters? Okay, so we're starting with 3.1, that's our number, liters is our unit, and helium is our chemical. So we'll take 3.1 liters of helium, place all of that over 1, and since I've got liters of helium, that should go down on the bottom of the next step. And we're looking for moles of helium, so moles of helium will go up top. In our conversion factors, liters goes with 22.4. So I'm going to fit in 22.4 there. And the unit mole goes with the number 1. So when we're doing this process, students who are first learning this often think, oh, mole, that's got to be 6.02 times 10 to the 23rd. We're going to use Avogadro's number when the unit says some kind of particle, atoms, molecules, formula units. If the unit is mole, we're going to pull the number 1 to go with it. Let's see, once again, we've got a bunch of 1s in our calculation that I don't have to type into the calculator because multiplying and dividing by 1 doesn't change anything. So I'm going to type in 3.1 divided by 22.4. And that's going to give me 0.13839 and a bunch of other digits. For units, the liters of helium have canceled out, and that's going to leave moles of helium. As far as significant figures go, that 3.1 has a grand total of 2 significant figures, which is our smallest, so we're going to round that to 0.14 moles of helium. Great. If you feel like you're getting the hang of this, starting with the next problem, once I show you the problem, but before I start working it, pause the video and see if you can work it out on your own, then resume the video and check and see if we got the same thing. So here is our next problem. It says that Bob Cat wants to inflate a balloon by sealing dry ice inside of it and letting the dry ice sublimate or turn into a gas, which is carbon dioxide, right? Dry ice is a special name that we give to the solid form of carbon dioxide, and carbon dioxide is CO2. It's a molecular compound, so the representative particle is going to be a molecule. If he wants the balloon to have a volume of 4.2 liters, how many grams of dry ice should he weigh out? Okay, anytime grams pop up in one of these problems, we're going to need the molar mass. So I'm just going to go ahead and pre-calculate the molar mass so that I have it when I'm setting up my dimensional analysis. So to figure out that molar mass, there's 1 carbon, and the periodic table says 12.01 for carbon. There are 2 oxygens, and the periodic table rounds to 16 for the oxygens. So that looks like it's going to add up to 44.01 grams for the molar mass for CO2. So to do our dimensional analysis, we're going to start with the number, the unit, and the chemical over 1. So 4.2 liters of carbon dioxide all over 1. And then we're going to put liters of carbon dioxide on the bottom of the next step to make that cancel with what we were given. In the top, I'm going to put the unit and the chemical we're looking for. We're looking for grams of dry ice, which is grams of CO2. Down from the stuff that came from the mole triangle, for liters, I've got 22.4. So I'll just plug in 22.4. And for grams, I've got the molar mass. So up top there, we're going to put that molar mass that we calculated a moment ago of 44.01 grams. And running that through my calculator, we're going to have 4.2 times 44.01 divided by 22.4. And that's going to give me 8.251875. And a cat just jumped in my lap. She doesn't do that very often, so kind of nice to have a little lap warmer here for a moment. Anyway, unit-wise, I've got liters of CO2 canceling with liters of CO2, leaving us grams of CO2. And as far as sig figs go, our initial number had 2 sig figs, so I should round this, and I'm going to end up with 8.3 grams of CO2. So if Bobcat can break off pieces of CO2 that weigh a total of 8.3 grams, dump those inside of a balloon, tie it off, as that dry ice turns to gas, it'll blow up the balloon until it has a volume of 4.2 liters. Let's take a look at the next one. Okay, this is part B. If this balloon filled with carbon dioxide has a volume of 4.2 liters, how many molecules of carbon dioxide will be inside? Well, we said that carbon dioxide was CO2. That's a nonmetal plus a nonmetal. So that's going to be a covalent compound. Another name for covalent compounds is molecular compounds. So our representative particle is going to be a molecule. And since it's asking for molecules, this is going to be Avogadro's number as part of this conversion. So let's start with our number, our unit, and our chemical over 1. So 4.2 liters of carbon dioxide over 1. And I need liters of carbon dioxide down on the bottom. And I need molecules of carbon dioxide on the top. And if I'm looking at what I have on our mole triangle, I've got 22.4 liters of a gas to go with liters. And with molecules, I've got 6.02 times 10 to the 23rd. Representative particles are molecules. In terms of units, liters of CO2 all cancel out. And so if I run this through my calculator, I'm going to ignore the 1 because dividing by 1 doesn't change things. So I'll have 4.2 times 6.02 times 10 to the 23rd divided by 22.4. Enter. And that's telling me 1.12875 times 10 to the 23rd. I can round that to 2 sig figs because I'm limited by the first digit, or the first number, the 4.2. This is going to give me 1.1 times 10 to the 23rd molecules of CO2. And I think there was one more related to this problem. Yes, part C. This problem isn't asking us about molecules of carbon dioxide. It's instead asking us about atoms of oxygen. So carbon dioxide is CO2, and that is going to be our representative particle for carbon dioxide, a molecule of CO2. So atoms makes us go that one extra step since atom is not the representative particle for carbon dioxide. So we're going to start once again with our number, our unit, and our chemical, being careful that we're talking carbon dioxide to begin with. So 4.2 liters of carbon dioxide over 1. And now this next step is going to be exactly like what we did on the previous problem. We need to put liters of carbon dioxide down here in the bottom. And we've got 22.4 liters from our mole conversions. And the closest we can get to atoms is atoms of oxygen is the representative particle, which is molecules of carbon dioxide. So up here in the top, I'm going to put 6.02 times 10 to the 23rd molecules of CO2. So molecules of CO2 is our representative particle. Representative particles go with Avogadro's number. So to get from the representative particle to atoms of oxygen, for every 1 molecule of CO2, well, that formula tells us we have 2 atoms of oxygen. So now, running all of that through my calculator, I'm going to have 4.2 times 6.02 EE23 divided by 22.4 and then times 2. And that's going to give me 2.2575 times 10 to the 23rd unit-wise. Let's see, liters of CO2 cancel out, molecules of CO2 cancel out, and we're left with atoms of oxygen. But we've got to round that. Our first number only has 2 sig figs, so we'll round that to 2.3 times 10 to the 23rd atoms of oxygen. So very much like the previous problem that took us to molecules, but once we're at molecules of CO2, we've got to double that number to get how many oxygens there are.